Yes, good afternoon to everyone, and let us take uh, let us take the unit number six. Unit number six. So the process, how the process will be, what are the different kinds of processes which are available. So with us in our Unix or Linux system, and what is the importance of the process and how many types of processes are there. Today we would like to discuss up to this moment what is the process, the meaning for process, and the parent and child process, and the types of processes, and remaining background and foreground process, and how internal external all these things will be discussed by tomorrow next class onwards. Okay, now let us come across what is a process and how the processes are going to be taken into consideration here. In the sense, simply speaking, a process is an instance of a running program. Whatever the program you have been written by you using C, C++, or any operating system program, however, whatever the program it might be, so whether that particular program will be in terms of in running mode, that running mode program will be called as a process here. As far as your operating system is concerned, I believe that you have come across with CPU scheduling in operating system. In operating system, you have several different kinds of process states will be there. New process state, new will be there, and process state, so ready will be there, and running will be there, and uh, uh, then followed by terminated is there. So likewise, we do have terminated. Likewise, we do have many number of process states are there, and you do have one particular diagram also there. So how the process is being evaluated. So you do have some process diagram also there. So, however, a process might be running of any instance of running of program will be called as a process here. And how a process will be considered here in the sense, so a process must be created, a process must be created by issuing any command in Unix or Linux. ls-l, for example, let me go ahead and take this particular so Ubuntu. Let me evaluate it. So, for example, so just before in the previous session, we have implemented how ls-l will be executed. A program has been created by us. Similarly, the operating system does also have a particular process, a particular program for ls-l. Soon we have to make this particular process, this particular invocation, then immediately it could be give some kind of output, and it will comes out from the execution of the process, and it will be shows you the prompt again back to the prompt here. Okay, so this ls-l will be one of the commands which is available with us in Linux, and it is a process, and it could be considered as a process here. So you can take anything, whatever it may be, that could be called as a process here. Okay, and a process will be, so always Unix will be always create the process in the sense, as and when you have to invoke any kind of command, obviously Unix will be assigned some space to that particular process, and so assigns space to that particular process will be called as creation. Okay, assigning space in the random access memory will be called as create the process. And after assigning the process, whatever this set sequence of operations which are used to execute for that particular process, they could be get started. So first command, second command, third command, and so on and so forth will be get started. Obviously, it could be gets executed. In this way, so a process will be took place within Linux or Unix operating system. And if you consider, as and when you have to invoke any kind of program for execution, it will be create a special environment. That environment might be having, so already you heard some particular name, process control block, PCB. In your operating system, you heard this particular name, and then followed by this PCB does have many number of items. That is process ID. So a process ID must be there. So process parent process ID must be there, and then followed by memory locations from which place to which place that particular process will be allocated in the main memory. That locations are there, and registers, whatever the registers which are used to execute. So for that particular process will be there. This environment will be created by Unix or Linux operating system. Okay, once you have to invoke any kind of process before going to evaluate or execute that particular program or process, so it has been create everything for that particular process here. And then followed by every process must be, as and when you have to invoke a particular process, just I have quoted 5-digit ID. 5-digit ID can be creates that which is called as a process ID, otherwise a PID. Okay, every process must be created with a process ID. That process ID maximum length will be 5 digits. Okay, 5 digits in decimal number only it could be. And each process must have its own unique process ID. Wanted to know about the process ID, you just give one specific command in Linux. At Linux command prompt, you may be give PS in the sense process state. Okay, so you could see the process ID and TTY, and then the time when it was introduced, and what is the command you have been executed here. So BASH is the basic shell which is used to execute your commands, and the process ID number will be 2652, and PTS, so 0. Let me give you what is PTS 0 over there. And that when it was started here in the sense, it was started so just before, and PTS 0, our PS, the statement which we have, the instruction which we have executed just before, that is PS. So the PS will be 2664. That is the process ID. So look at this. These two processes will be identified with the two different numbers. Okay. So these numbers are always unique numbers. Always unique process IDs. Okay. At any moment of time, so two processes cannot have same number. Okay, two processes cannot have same number. So look at this. As far this particular example is being concerned here, so within this particular example, so PS is being executed and it has been displayed the complete information, and process gets over. This execution of PS is over. Now there is a possibility to assign the same number to some other process if any other process will become to comes for execution. Okay, because PS is taken its location and it has been executed and displayed to user, and it will be gets over, terminated. Process is gets over. So 2664 is now it is empty. Now it is vacant. So if you run any other process, so then there is a possibility to assign same number to that particular same process ID to other process, because if that particular process gets over, there is a possibility. But if two processes are being running, they are let us consider that they are at running mode. So no two processes will be having with the same kind of process ID. That is what the concern of this unique process ID here. So that is if a process ID A can be allocated to process ID B only after the execution of process A must be completed. Okay, if any process ID, A's process ID will be allocated to B process when execution of process A must be gets completed. Then only it could be allocated. We are not sure, but there is a possibility. There is a possibility to allocate. Okay, and then followed by at any moment of time, two processes, when processes are in running mode, processes are running mode. So no two processes are the same PIDs. Okay, no two processes will be taking same PIDs. because your Linux or Unix operating system, not only these two, any kind of operating system, whatever the operating system it might be, so they will be track the process based on process ID only. Let me show you the process ID as far as Windows operating system is being concerned. Windows operating system, you please open Task Manager, something like this, and here Task Manager could be gets open. So here you could see performance. No, where it is? Application history. So if you time normally here process IDs are what we call they are in hidden mode. They could not be given because it is always gives the information regarding the name of the processes, but process ID cannot be given. And you could see somewhere else. One moment, please. .msc services.msc. I believe that the things will be available with this particular services.msc. Yes. In services.msc, you could see the process IDs 2060. So look at this. Okay, let me close this one. Here you can see 2060, 1964, 28, 2868, and so on and so forth. You could see some numbers are available here. For some process, numbers are available here. These are the process IDs. These are the process IDs. So these process IDs will be, so in this particular whatever the process it might be, it must be always tracked by using this particular number. Okay, this particular number. So therefore, so process ID will be given by any operating system, not exactly Unix or Linux. Any operating system will be gives this particular process ID. Okay, then so starting of a particular process, how a particular process will be started here in the sense, there are two ways to be start a particular process. One is foreground process, and second one is so background process. There are two different types of processes are there: foreground process and background process. Basic difference between these two. What is the basic difference between these two here in the sense? Foreground process is always so this particular process is always take the help of keyboard. So keyboard. Okay. So if you are trying to invoke any kind of process, you must give that particular process name at the $prompt. Okay, something like this. You must give that process name. Let me say ls-l. If you are supposed to type ls-l using your keyboard and then invoke and then press enter key, then it could be gets executed. So such kind of processes will be called as foreground processes. They are being executed at that moment, and it will be so complete the process execution and will be sent to the screen. Such kind of processes are called as foreground. Background in the sense, in the converse, background in the sense, no need to have the keyboard invocation. Keyboard is not required for this. Sometimes it may be required. If it is required, it could be wait for some time. Okay, so they will not be shown to you. So look at this. Already I show you. So within this particular thing, so PS process status. So just before ls-l process is completed, but it is not shown here in the process status. It is not shown here because that process gets over, and BASH is continuously shown to you because BASH is working at background mode. So since if it is not available with you, you could not see this particular $prompt for execution. So therefore, it must be executed at background. You are not executing or you are not giving any statement or any process such as BASH with your keyboard. So that is why keyboard is not required. Okay. So such kind of a process are called as so background process. Same information will be there. So foreground will be always run with the help of a keyboard. Okay, and sends the output to the screen, and background will be always so it must not be required. So 99% it is not required the keyboard input. If required, it could be wait for keyboard availability. If required, it could be wait for keyboard availability. Okay, so in background, many number of processes are being running. Many, as much as many. I will show you how the process will be so run here. At background, many parallel processes are being running here, and so So they could not be wait for previous process to be completed. Whereas if you take any foreground process, so if you want to execute, let me say, first you are expected to execute ls-l, then followed by cat any particular file name, then followed by so ls so -l, so followed by more. If you want to execute this set of commands in the sense, first of all you need to complete this one, then you could able to type this particular command and can be complete this one, then you could able to type this command, then it could be able to complete. Okay, so if you want to execute in a particular order, everything must be taking the help of keyboard, and everything could be so executed after completion of first command, then you will go ahead with the second command. So in foreground, no process is running at parallel, but in background, yes, it could be many number of processes are be running at background here. And if you want to if you want to say, if you want to push your currently executed command towards the background, you just add ampersand sign. Let me show you how this could be. So look at this here, clear. So ls-l, if I would invoke enter key here, immediately it could be display the contents and immediately turn to command prompt. Look at this, immediately command prompt will be displayed here. Okay, now ls-l, so ampersand, if I were to press ampersand here, then you could see it could be wait for because this process has been pushed into background mode. How could you know this is pushed into background mode? Let me open one more terminal for you, then I will show you. Yeah, this is one more terminal. So look at this. This terminal is different from this terminal. Both are not same. Okay, both are not same. So look at this PS. If you type PS, it could be displayed to you only the processes which are running within this terminal. Okay, this is TTY0 and this is TTY1. Very basic. Yeah. So it is PTS1. This is PTS1, and the below one is PTS0. Okay, let us have a look. So if you want to get the information regarding to all processes which are under background, so PS-EF. F in the sense full form, E in the sense extended full form. Okay, -ES. You could see somewhere else, you could consider here. So our process is being executed here, and ls-l somewhere else it could be. You have to check it out. Somewhere else ls-l could be available. Where it could be? Where it could be? Okay. Okay, we will see. We will see where somewhere else it could be. So there are huge number of things. I'll show you how this could be, how the things will be. If you want to come out from the background, just press enter key. So it could be goes for +1 and done. Okay, ls-l. Okay. Now let me go ahead and take the UP class lab. I have created one particular file cat.a.c for showing the process status a.c. Let me execute this one for a while because it is being taking some kind of input here. Okay, scanf %d %d, two inputs are trying to take by this particular program. So therefore, let me gcc a.c-o a. Yes, executed. It's under GCC is completed. Now let me execute a.a. Okay. Now it is waiting for taking input here. It is waiting for taking input here. Now let me go ahead and take so second prompt, second screen or second terminal, and apply the same command one more time. PS-EF. You could see so /a. You could see this one here. It is also at running at PTS0. I hope that you understand. I told you this is PTS. So this one is PTS1 and the previous one is PTS0. At PTS0, so /a is being executing. Let me take one input here, some 10, enter. still it is being available or not. Let me see. Let me see this one. Let me show you one more time. One more time. Let me execute this one. Yes, it is still executing. Okay. Then some 20 as input, and the process is completed. Now the process is completed. Go and check about this one here. There is no slash here. Okay. There is no slash here. So therefore, you could able to see such kind of processes which are being waiting for some kind of input within the process status. Okay, so they will be pushed into background process by specifying ampersand here. Okay, like this. Just now I told you in the similar fashion. Okay. Then, how many processes are there? How many number of kinds of processes are there? Processes are three types. One is parent child, and if you consider anything, if you consider any process, let me show you back one more time with the same kind of thing here. You could see this output. Wait for a while. Yeah, this is the specific output here. User ID, PID, PPID. PID in the sense that is the process ID. PPID in the sense this process was created by this particular process, parent process ID. Parent process ID. So time, how much time it could be, and what is the teletypewriter, TTY in the sense teletypewriter. That is the meaning of TTY, teletypewriter. And what is the command which is being executed here? Okay. So here PID, PPID. PPID in the sense parent process. So normally all commands PPIDs will be, so it's shell only. It's shell in the sense that might be BASH will be the PPID for all processes which we have to run for that particular thing here. So each system process, each process must be having its parent process. If parent process cannot be there, your process cannot be created. That's what you need to remember. So at least one parent process must be available to execute a new process here. Okay. Normally, so ls-l must be operated at dollar prompt here. So here ls-l, whatever the command it may be, I'm taking this particular example at this moment. So this command is being executed here. This dollar itself is called as a particular process, background process. That process is BASH. That is the BASH. This BASH will be parent process of ls-l. And you could take any command at this particular time. BASH will be the parent of that particular process. That is the meaning of parent process here. And most of the commands, if you take whatever the command it may be, whatever the programs you write it may be, shell will be its parent. Shell will be BASH will be its parent. Okay. Then so here some other processes are there. Jumbai process. What do you mean by Jumbai? What is the importance of this Jumbai here in the sense? So for example, so ls-l will be there. It is being executed right now. So ls-l was created by bash. So this is the parent, and this is the child. Okay. So if a child will be correctly executed and terminated, then bash is being executed back, or it is going to execute it's a set of commands back. But so on execution of a child process, if you intentionally terminate this parent process, then this process will be orphan process, because every process must have PID and every process must have a PPID. If PPID could not be there, obviously such kind of processes will be called as Jumbai process or orphan process. They will be called as orphan process. So why they could be comes into orphan in the sense its parent process was killed, its parent process was terminated before completion of this process. So that is why that is called as orphan process. So such kind of orphan processes will be also available with us, and these orphan processes will be available within the PS-EF with Z. There is a character. So at TTY there is a character that is Z. I'll show you. I'll show you. Probably Jumbo processes are not available, I think. They are not available. They could not available at this moment because we are running with only single system. That is why Jumbo process cannot be there here. So here at C, so here Z will be available. Z will be available here. Okay, we will see. So this how to create a Jumbo process and how they could be. So we will see all of them. So but here Z will be there. Then if Z will be there, that is an orphan process. So that process doesn't have any parent, since the parent was killed by the user intentionally. So therefore, such kind of a process are called as a Jumbo process or orphan process. Okay, please remember that Jumbo process or orphan processes. Okay, then daemon processes. Daemon process in the sense they are all background processes are called as daemon processes, and they are not looking for anything. Sorry, they are not. They are looking for something to be happen. For example, spool, S-P-O-O-L. I'll show you in terms of taking the example in terms of MS Windows operating system. So look at this. There is a process. There is a process which could be S-P-O-O-L. I'll show you. Otherwise, you could see. You could see. Look at this. Oracle TNSLNSR, Oracle listener. So this is the specific process. I don't know whether you can view or not this one. So Oracle TNS LNSR executable. As and when if you open Oracle terminal and if you are trying to connect with user, that is my username is Gopi, and with the password, as and when you have to type that username and password, then this TNS listener will be comes into the picture. Look at this. This could be evaluated. Okay, it was connected. You could see it was connected. So let me show you. I'd like to stop the. I'd like to close this one for a while. I'd like to close this one for a while, and let me stop the execution of this service. Let me stop the execution of the service for a while. Where it is TNS listener. I'd like to stop for a while. Yeah, this one. It is already in running mode. It is already in running mode. Let me stop this one for a while. Stop. Yes, it has been stopped. Then let me try to open the Oracle again and running with so username and proper password only. Password is also right, what I was entered. Oh, it has been evaluated. Okay. However, so let me stop this one also. Which one? TNS listener. This one also. WarCL also. Let me stop this one also for a while. For a while, let me stop that one also. Then you could see what is the problem which could be raises. It will take 1 or 2 minutes to 1 minute to stop this complete process here. If you stop those processes are not alive right now, because look at this. This process will not running at this moment. It is a background process actually. All these background processes are called as daemon processes. These are called as daemon processes, and these daemon processes will be always waiting for user process evaluation or execution. User process evaluation or execution. Okay, it will be take some time. Yes, it has been over. The daemon processes gets stopped. Okay. Now look at this. Look at this, and I will open one more time this Oracle. I'm trying to communicate with this. So look at this TNS protocol adapter error. So these two processes are not in active mode. This one and where it is this one. These two processes are not in active mode. These background processes must be in active mode to connect the Oracle here. To connect Oracle, these two processes must be in active mode. Unless otherwise, it could not be connected. And here you can see one more process here, spooler, print spooler. So if anything you are trying to give some printing So if your printer is connected, then immediately this particular process will be activated and communicate with the physical device, that is printer, and the data will be sent to the physical device printer. If it is not activated, if it is not running mode, obviously your printing cannot be comes out. In this way, so these daemon processes are being took place here. These are the daemon processes, and such kind of processes are called as daemon process. System related process are this, and they could be taken into consideration, something like this. Okay, and the daemon processes cannot be controlled by any terminal. So terminal in the sense you do have PTS, you do have a pseudo terminal device. Otherwise TTY in the sense teletypewriter. So these are the two different types of terminals which are available. TTY will be default kind of terminal which is being displayed for you. PTS in the sense your terminal what you are supposed to open for command line, that is called as PTS. If you observe some number of daemon processes, those daemon processes will be displayed at the place of you could see at the place of TTY area. So question marks will be there here. I believe that you understand. You can see this one, question marks. If a question mark will be there, all these things will be daemon processes. All these processes are daemon processes. It is a TTY1. Yes, it is being executed some script somewhere else. It is also TTY1. It is also executed somewhere else. And you could see some other process. All these processes are being executing. Okay. PTS1 bash is being, now it is bash, it is being executed. Process -ef, it is also being executed. Okay, so this bash is executed at so one more thing, that is let me say this one, two different types of terminals are being opened here. So at first PTS0 bash is executing, at PTS1 another bash is being executed. This question mark in the sense it is not supposed to be considered as a foreground processor, and it is called as a daemon process, and which is being maintained by the root. Okay, so these are different kinds of process which are being available. So you could see. Okay, let me erase everything, then you could understand. So where exactly, so at a TTY place, where exactly question mark will be displayed, such kind of things are called as daemon processes. Daemon process in the sense system related background processes. Okay, and these process will be usually waiting for things here. Already I have given one example here. A printer daemon is waiting for print commands. Okay, a TNS listener is waiting for Oracle connection. ORCL is waiting for Oracle connection. Okay, user connection, something like that. They are always waiting for things will be happen. If things will be happen during that particular session, they will be respond. Otherwise, they will keep running. That's all. They will be continuously keep running. That's all. Okay. So this is what about today's class, and these are the different kinds of things which have been evaluated today. And tomorrow, the commands which are related to these processes will be discussed by tomorrow itself. Okay, tomorrow in the sense next class. Okay. Thank you.